Okay, if we go by the sequence of things that we've learned, after we learn quadratics, or rather, after we learn trinomials and factoring of trinomials, we looked at rational functions. So, because the method is very much similar, we are going to learn about rational inequalities. Rational functions are functions of the form px over qx, where qx is not zero, and p and q are polynomials. Example, 3x plus 3 over 2x plus 4 greater than 0. Now, before we learn how to analyze that, let's look at a very simple example of just a fractional number. Now, when is a fraction a over b positive or negative? There are four scenarios. You have two numbers, either of them can be positive or negative, so 2 times 2, four possibilities. If a and b are both positive, then the fraction is positive. If a is negative and b is positive, the fraction is negative. If a is positive and b is negative, then the fraction is negative. If a is negative and b is negative, the fraction is positive. So this gives us the idea that we should look at numerator and denominator separately. Because if we know the behavior of each of them, then we can determine the behavior of the ratio. So in this example, when is 3x plus 3 positive? That's when x is greater than negative 1. When is 2x plus 4 positive? That's when x is greater than negative 2. Now we want to see the overlap of these two, right? So we put these numbers on the number line. To the right of negative 1, the numerator is positive. To the left, the numerator is negative. To the right of negative 2, the denominator is positive. To the left, it is negative. Now, if you look at these regions, there are three regions. On the leftmost, numerator and denominator are both negative, so the fraction is positive. In the middle region, numerator is negative, denominator is positive, so the ratio is negative. And on the right region, the ratio is positive. So if you want the whole fraction to be positive, it's in the left and the rightmost region. This is an intuitive way for solving the rational inequality with just an idea of how fractions work and applying it to rational functions. It's a little cumbersome because you have to be careful about when the signs change, or for example, if you have a whole square in the denominator, it works, but it's not the most efficient way of solving. In the next video, we're going to look at a more general method.